you believe that human activity, based on your belief in science, is contributing to climate change?
The increase in the greenhouse gas concentrations in the atmosphere are having an effect. Our ability to predict that effect is very limited.
What are some model predictions in the past that have later turned out to be correct, like models from first principles predicting properties of climate that were only confirmed in subsequent observations?
Just the whole warming of the Earth that's occurred over the last few decades was a prediction of the climate models that has essentially come true.
This is the first three-dimensional model result that was done by Manabe and his colleagues at the Geophysical Fluid Dynamics Laboratory at Princeton.
I was a graduate student in the 1980s, and we had been looking at the warming trends and comparing that with model projections.
How can we predict what our future atmosphere will be like because of the greenhouse effect? This is one way, using a computer model of the atmosphere here at NASA Goddard.
We predicted 2 years ago that by 1990 you would see a warming of several tenths of a degree.
There was no doubt that fossil fuels were the main driver of higher CO2 emissions, and that CO2 emissions would lead to climate change, right? What Exxon was trying to figure out in the 70s and 80s was, when is it going to hit and how bad is it going to be? But they knew it was going to be bad. Like, they admitted it's going to be bad. They used the word catastrophic over and over again.
The actual temperature rise since my first major paper in 1981 has actually been faster than what we calculated then.
The model said, that sometime in the 1990s, the signal should start rising out of the noise.
November 1995, Madrid, the scientific community really got together and said, that's it. It's a complex problem, but we've seen the evidence and it all points in one direction.
And it's not just the global mean temperature. What's important is the spatial characteristic of it.
What happens in the upper atmosphere is, with more CO2, the atmosphere being so thin, it can just sort of radiate more effectively to space, and so the stratosphere cools.
The stratosphere has been cooling, at the same time the lower atmosphere has been warming.
So that's a prediction that the models make. That's exactly what happened.
And that pattern, that distinctive pattern, warming low down, cooling up high, is fundamentally inconsistent with natural causes.
So if it was something like heat coming out of the ocean or solar variability, you would expect the stratosphere and lower atmosphere to move together.
And in the end, we got a nice curve, a curve that showed the temperature. And it was rising. I tried fitting it to an exponential. It actually wasn't a very good fit. Tried a parabola. No, that wasn't a good fit either. Okay, try the US population. Well, it wasn't so good. We tried this in many different ways. Tried just the straight sunspot record, running averages of the sunspot record, the IPCC function of solar intensity. We tried all of them. They didn't contribute. Try carbon dioxide. Smack on. So I was flabbergasted. Not only was global warming real, and roughly consistent with what the previous groups had said, but the match to carbon dioxide and the fact that solar variability was not responsible enabled us to rule out the primary alternative theory.
The other thing that was predicted was that the high latitudes would warm more than the low latitudes, so the polar areas, especially in the north.
The temperatures will increase more so in the Arctic region, less so in the tropics.
The lower atmosphere sort of warms 2 to 3 degrees at most latitudes, but there's an amplification of the change in polar regions.
We know that the Arctic is being impacted much more dramatically than we are here in the mid-latitudes.
Some of this is due at least to this ice albedo feedback mechanism.
As the shiny white ice and snow melts and gets replaced by dark ocean and dark land surface that soaks up more of the sun's energy.
Models predict that lower latitudes warm up less than high latitudes. Well, did that happen? Yes.
Another projection was that the northern hemisphere should warm faster than the southern hemisphere because the land tends to be more on the north than in the south, and so the ocean acts as a big thermal heat sink, and so we would expect the southern hemisphere to warm more slowly than the north. That's exactly what's seen.
Models predict middle of continents warm up more than middle of oceans because of the heat capacities of the system. Did that happen? Yes.
We've done a bit of work looking at how the spread of climate models from the latest IPCC report compares to observations. Right now, at least, particularly with the current El Nino, observations are a little above the model mean. For the last decade or so, they've been a little below the model mean, but still well within the spread of climate models.
But other changes in our weather could be even more important than hotter summers.
Changes that could perhaps be starting already. The shifting of precipitation patterns from place to place, changes of the atmospheric winds, which mean that some people may actually start to see different storm patterns.
So in fact, early work with climate models had projected that there would be a shift in these storm tracks with the rain moving out over the ocean away from the land in parts of the southern hemisphere, and we are now actually seeing these changes take place.
Models predict night warms up more than day because of a variety of factors. Did that happen? Yes.
It has been over 50 years since climate scientists formally warned a US president of the dangers of climate change. We have known that humans are affecting the climate of this planet since the late 1800s.
Science tells us that the climate is changing, and then human activity in some manner impacts that change. The ability to measure with precision the degree and extent of that impact and what to do about it are subject to continuing debate and dialogue.
Some people say, well, there's something else going on. And I say, what's the prediction you make? Oh, I don't know, it's random. Now, that's not what we call a scientific theory. If you say, well, it's something else and I don't know what it is, my answer is something else that just happens by accident to perfectly match the carbon dioxide increase. Are you serious?